Now, so under the chapter of redox, redox, yeah, right? I only want to cover 5 points. And if you can do all these 5 points, you're done. Go and do questions. Don't say, sure, I go and study redox, then I'm going to read textbook again and again. If you know these 5 points, means you're okay already. Go and do questions. Now, what are the 5 points? Number one, whenever I teach chapter on redox, you must be able to explain oxidation and reduction in terms of oxidation state, hydrogen, oxygen, electrons. And for those of you who were here previously when I covered redox, you should know what SHU is. But since this class was only formed this year, I think nobody. Yeah, so anyway, now SHU stands for oxidation state. Oxidation state. That's S. H for hydrogen. O for oxygen. E for electrons. Number one. And number two, just recall this. It's plus, minus, plus, minus. Plus, minus, plus, minus. This is oxidized. And minus, plus, minus, plus, reduced. And that's your 4 definitions of oxidation and reduction. What this means is, let me just run through one at a time very quickly. If oxidation state increase, oxidize. Loss of hydrogen, gain oxygen, loss electrons, oxidation. What is reduction? Oh, when there is a decrease in oxidation state, gain of hydrogen, loss of oxygen, gain of electrons. That's that. Yeah, so if you're able to do that, level 1 done. Now, the second skill is to calculate your oxidation state. Can I just check? Anyone not very confident on this? Okay, can. For compounds or for ions? Generally cannot. Okay, can, cool. All right, now calculating oxidation states can be tricky. And I want to say it really depends on the type of compound you're given. I'm going to try and start with something simpler, something common. But I think maybe useful to also recall a few rules. All right. Elements, oxidation state always 0. All right. If you're a group 1, it's +1. Group 2, you are +2. Of course, this is in a compound. All right. And what else? Oxygen, I would say majority of the time is -2. And hydrogen is +1. So these are things that I think, once again, this part here, all in a compound, sorry, in a compound. So if I give you an element by itself, then because it has not yet undergone a reaction, there's no charge. On the other hand, if I give you a compound, then compounds, all right, depending on where the element is in the periodic table, you determine the charge. Now, what do I mean? I give you a few examples. Let's start with something really simple. Let's start with what we just did, which is periodic table. So let's say you have chlorine and you add that to potassium bromide. We just did this reaction, right? You're going to get potassium chloride and bromide. Now, first things first, we need to recall all elements by themselves have no charge. Chlorine is 0 and 0. Make sense? Now, on the other hand, all right, I'm also going to say this. We ignore the number in front, okay? The number in front is used to balance the chemical equation. We're going to ignore the number in front. All right, okay? And then what about potassium bromide? Now, I know it's quite simple. It's not your lecture, so easy. Okay, that's fine. But for example purposes, potassium bromide is a compound. So when you're given a compound, what you want to do is always split into elements. All right? Potassium is in group 1. And therefore, oxidation state is +1. All right? And then you can derive bromine, or you can go to bromine group 17. All right? Isn't it -1? Yeah, also can. Bromine group 17, -1. Remember, Ken? All right, okay. So a few things I talked about. I talked about elements. I talked about group 1. Now, some students will go, sure, bromine also -1 because group 17. Now, let me show you something. Let me give you another compound known as potassium chlorate. Okay, so this is example 1. This is example 2. Let's give you KClO3. And I say, find oxidation state of chlorine. Now, if the question says, find oxidation state, right, you cannot go to periodic table. Right? If they say, calculate oxidation state of chlorine. Now, when you see this word here, usually what they mean is cannot just refer to the periodic table. Cause we're wrong one. Oh, chlorine group 17 minus 1, gone. GG, 0. No. So what you want to do, same thing, you want to split your compound into elements first. Okay, okay. Now fill in here. Fill these in first. All right. So what I'm trying to say here is this. If you see an element, if you see group 1, group 2, oxygen, hydrogen, fill those in first. Okay? I see group 1, oh, +1. I see oxygen. Each oxygen is -2. 3 of them is -6. And if you are lost here, please let me know. Cannot. Where cannot? Okay, again, huh? So potassium group 1, right? Can I? Wait, I rewind. This part can? Sure. Can? Okay, so here, back here. Now, so potassium chlorate, okay? Potassium is group 1, correct? So group 1 in a compound is always +1. Now, oxygen in the compound is always -2, right? But here is O3, man. Got 3 oxygen, right? So times 3. Right? -2 times 3 is -6. Okay? Maybe I put a bracket. I don't know whether that help. -2 times 3. Maybe I write bigger. I mean, I don't know what else to do. Okay? Where was I? Last one. Then now you need to recall this, and this one is the finishing step. All right? You need to understand that all these numbers must add up to 0. So it becomes basic math. Basic math, right? 1 plus something -6 must add up to 0 because all compounds are neutral. Have you done redox at school? Right, okay, cool. Now I just need to check because if you haven't done, then this is like a nightmare because it's like too fast already. All right. And then if you do that properly, Nicola, what do you get? +5, sorry. Yeah, +5. That's it. That's calculating oxidation states. Okay. All right, okay. So later on, I think you get more practice, but I want to do just one more because sometimes you get like ions. Sure, you never teach ions. Okay, fine. Ions. For example number 3. Okay, I give you like a carbonate ion. Calculate oxidation state of carbon. I write bigger because too small cannot see. CO3 2-. Same thing, step 1. Whether or not it's a compound, it's an ion, split it into your elements first. Now, those of you at home, if I'm going too fast, please let me know. All right. Yeah. Step 1. Fill in everything in the table. Your element. Any element, don't have. Any group 1, don't have. But there's oxygen. Asher, come, Asher. Each oxygen is -2, right? Got 3 of them, right? Total is -6. Can I? Just give me. Now, this is a bit tricky because this is an ion, which means what? The overall charge now will not be equal to 0. It will be equal to the charge of the ion, which in this case is -2, oxidation state. And so, you think, Ken, so far? Sure. You think, help me? Ken, what is the oxidation state of carbon? Any idea? +4. Thank you so much. +4. +4 -6 is -2. Ashley, Ken? Okay. So skill 2 is calculating oxidation states. I think if you can do that, should be quite okay. Listen, okay? Sure. You're not, that's not redox, right? Okay, can. But you learned it, right? Okay. Now, skill 3. What is skill 3? Okay. Skill 3, you must be able to identify and explain why a reaction is redox. So you typically, most of the time, the exam questions will ask you to use either oxidation state or electrons. So you must compare, right? After you fill in all the oxidation states, you must be able to compare your reactant and product, and then tell me whether or not oxidation state increase or whether or not it gains or lose electrons. All right. So this one, I think I'll run through later using the word examples. It's a bit easier later. Okay. Skill number 4 you must be able to identify your oxidizing and your reducing agents. And very quickly, your oxidizing agent is a substance that is an electron acceptor. Why? I said this earlier on, right? If I go to you and I take away all your electrons, you become less negative, become more positive, you get oxidized. That makes me an oxidizing agent. All right? And then what is an electron acceptor? Usually your non-metals. On the other hand, your reducing agent, will be your electron donor. If I'm a reducing agent, means I go around reducing other people. I make people more negative, make people more sad. Okay, I'm kidding. All right, okay. So if I go to you and I give you all my electrons, all right, you become negative, you get reduced. Reduced like sad state. Okay, now so that's how I memorize it. All right, so and then these are your metals. Metals make people sad. Okay. All right. Of course, they like to play around with terminology. All right. So a stronger oxidizing agent just means a more reactive non-metal. A stronger reducing agent just means a more reactive metal. Okay, so just watch out for things like that. All right. Maybe some of you need that. I say again. Maybe I put here. Okay. Sometimes you see the question. Okay. Stronger oxidizing agent means more reactive non-metal. I help you to put one and one together, okay? And of course, if they ask you, oh, which is the stronger reducing agent? Typically, is the more reactive metal. All right? Of course, there are other examples like KMnO4 and Ki. Should I put them here? I'll tell you what, hold on. Some of you are going to kill me, but I'm sorry. Hold on. I shift this down. I add one more, okay? Please don't. I'm sorry. All right, now you have KMnO4 and you have Ki. So potassium manganate 7 is a very common oxidizing agent. All right, it's a purple color solution. We will cover this extensively under the chapter of organic chemistry. And Ki is a very common reducing agent. All right. Why? The iodide ion. Ki got the iodide ion. All right, can donate electrons. Iodide ion, right? Touch another person, right? Iodide give the electron away. All right, then the other guy gets reduced. So potassium iodide is a common reducing agent. Almost done, almost done. I said 5 skills, right? Once you, okay, the last one is memory work. All right, the last one, I need to write in blue color. All right, point number 5 is test for oxidizing agent and reducing agent. How do you know if something is an oxidizing agent? Very simple. All right. OA test. Add Ki. Equals of course. If colorless, solution becomes brown, OA present. This is purely memory work. All right. Reducing agent test. Add acidified KMnO4. All right. And then if purple solution turns colorless, then RA present. Okay. The A, sorry, I shouldn't have taken shortcuts in life. A stands for acidified. Okay. Thanks for asking.